All right, everybody, 10 o'clock. Thank you for coming. I am actually standing in for Nick Bryant today, who's having some technical difficulties. Wait for everybody, Nick. Today, we're just introducing Russell. He is with Rebound Technologies. He's going to be presenting on their ice storage solution. So, Russell, I'm just going to go ahead and kick it to you here to take it away.
Awesome. Let's do it. Yeah, so like Bobby said, we're talking about Rebound Technologies today and our ice storage and refrigeration technology. I'm going to start off. I'm the CTO and founder of the company, and we've been working on this technology for a little over 13 years now. And I want to start by talking about kind of where we came from, what we saw happening in the market 13 years ago when we started the company. We saw this shift on the energy and technology side where time of use rates, peak demand, decarbonization, these forces were kind of putting a lot of pressure on the HVAC and refrigeration industry. At the same time, customers are demanding much more flexibility, much more adaptability out of their cooling products. They want to know, when is the refrigeration system or the HVAC system running, and how is it delivering value to them. And we really saw these two intersecting as an opportunity to kind of rethink to rethink ice storage and to rethink energy storage around those two problems. So we created this technology stack that we call IcePoint. It manifests as two different product lines. We have a C series line that deals with high temperature cooling above freezing. And then we have an F series line that deals with low temperature cooling all the way down to minus 40. And I'm going to talk mostly about our C series today, but I'm happy to field questions if anybody has them about the F series. And I'm going to go through a couple applications, but really, we can apply our technology across the HVAC and refrigeration spectrum. So let's dive into the product. The product is an ice storage system, and I think we're all probably somewhat familiar with ice storage. This is quite a bit different from a technology standpoint. I'll get into that in a second, but I want to highlight the value, right off the bat. So the number one value of the product is what we call agile cooling. This is the ability to be both asynchronous and asymmetric. I'll define both those terms. Asynchronous is what we're familiar with ice storage. We buy 300 kilowatt hours of cooling in the middle of the night, and we use it in the middle of the day. And our product does that just like any ice storage system. What we're bringing to the table that's new is this idea of asymmetry. And what that means is our system is a 25-ton system. It produces ice at 25 tons. The compressor is sized for 25 tons. The condenser is sized for 25 tons. The cost is similar to a 25-ton system. The delivered cooling, though, can be up to 150 tons. And so what we can do is we can run for 12 hours of ice making at 25 tons and then run for 2 hours at 150 tons. And this, when you look at variable loads or volatile loads on the customer side, can deliver a lot of value, and often can result in our system being cost equivalent to a chiller or even cheaper than a chiller. And so we'll get into how that plays out. A couple other values in our system: everything is plug and play. So, it's just a box. It sits outside. You connect power and coolant lines and you're done. There's no system engineering around what chiller should go with what ice tank, should go with what valves. All of that is built into the system. We're really good in high latent load facilities because our coil temperatures are low and our sensible heat ratio is really good. We tend to excel at those kind of loads. And then also we deliver all the energy savings of a traditional ice storage system with the added benefit of the agile cooling leads to a lot of really great impacts on connected load and interconnection. And I'll hit on that in a little bit. But before we get to that, what is actually in our box? What have we done that's different? Why did it take us 13 years to make this technology? So what we realized right off the bat when we started is that ice storage needs a specific solution. We can't just use the ice making technologies of the past to solve the problems of the future. And so we developed an ice maker from scratch, specifically geared towards thermal energy storage. We do really advanced surface chemistry that basically amounts to we grow ice on top of a liquid layer, on top of an oil, and we harvest it with subcooling. We harvest in about 20 seconds, and we grow very thin, very efficient quarter-inch thick ice. Overall, this gives us 10x more ice making for the same surface area as a traditional system. And you can see this video on the right of our test rig harvesting, very quickly. What that results in is just a lower capex. So we're 10 times cheaper than a thermally harvested plate ice maker, and we're less than half the cost of an ice on coil system. And the other big thing that it does is the service of our system is just like a falling film chiller. You can open it up, you can access all of the piping, all of the heat transfer surface area really easily. And so serviceability becomes very, very easy. We've made a lot of ice. I've watched a lot of ice grow, and we do have equipment running in industrial environments. So the other thing I really want to harp on here is this idea of plug and play. I think plug and play is thrown around a lot. We really mean plug and play when we say plug and play. And as a comparison to kind of the old way that we've done ice storage systems, you had these bespoke engineered products where you had ice tanks and chillers, and you're trying to combine all of this. And here we're really doing away with that. We have a product that's completely designed, fabricated in a factory, and it really just needs a concrete pad to go down onto. That gives us a couple really big benefits. One, the project cost is a lot lower because we don't have any design work going into the project. And the chiller operation or the compressor operation is a lot more efficient because our compressors are designed to only make ice. We've picked a technology and a compressor that's running right at its optimum middle of the envelope kind of efficiency. And we're not asking a chiller to run, half of the time at a 40-degree suction temperature and half of the time at a 20-degree suction temperature. So all of our refrigeration system is designed explicitly for exactly the case that we're looking at. And so when you look at our product, everything is designed, packaged in this unit. We use R32 as a refrigerant in the product, and we're really able to get this agile cooling because we have this tank full of ice. The ice is very accessible, perfectly kind of in that sweet spot between accessible but not a slurry of tiny little flakes that makes pumping hard. So to go through some examples really quick, we have, this is a retail example where the volatility here is created by demand response. And so what we're able to do is we're able to, during this 3-hour window in the afternoon, deliver 600 tons of cooling where a traditional ice storage system would not be able to ramp up to that amount of cooling without being really oversized. So we can reduce energy costs by 70% and drop the capex of the total system by peak shaving the rest of the time. To look at a data center, here we have a flat load. Similar, what we're doing here is we're doing a resiliency play. So we deliver 12,000 gallons of ice storage that gives them 15 minutes of full facility backup cooling in case of a power failure. And then we're able to deliver this huge demand response asset as well that allows them to interconnect into the grid a lot easier because their connected load is reduced during that peak period. And that offers them a lot of benefit. And then one more example on the food processing side of things, we have a wash down recovery example where here in food processing, you have to spray down the facility once a day and to sterilize everything. That creates a really hot, humid environment that that you have to recover from. During that time, that's perhaps a 4-hour window. During that time, your entire facility is idling. So it's a huge waste of your assets, but you can't oversize a chiller to only run 2 hours a day. The economics just don't work out. So here, what we're able to do is we're able to run for almost all the hours of the day, give them some free demand response in the middle of the day, just as a kicker, and then we deliver all of our cooling in these 2 hours at the beginning of the day to recover from washdown. So this gives the facility back 2 hours of operational time every day. Obviously, that's a huge value, and we're able to do that at a much lower CapEx because of this agile cooling trait of our technology. And in food processing as well, you have a lot of batch cycles, batch processes where you have these kind of spiky loads, chilling a product before it's packaged, chilling wort out of a reactor, something like that. So, a lot of applications there in food processing. Final slide, just going over some product specs here. The unit is 20 by 10 by 18. It sits outside. It can be customized to tie into chilled water loop, glycol loop, or to run directly to a close coupled air handling unit. While our ice maker is, this new technology, the actual equipment that's running it is dead simple off the shelf stuff. We're running R32, we're running scroll compressors, oil separators, the normal, everything you would expect to find in a refrigeration system. And so serviceability is really straightforward. And we're really looking at applications anywhere you have really high time of use rates, you have really high humidity, you have really volatile load, ideally the combination of all those things. Right now everything is contract manufactured, and we're really looking for, those initial niche markets where this technology can offer a lot of value because of this ability to do agile cooling. And with that, I'm finished. So thanks so much for joining, and thanks for the opportunity to talk to you guys about ice storage.
All right, I'll take over for Nick. Russell, thank you very much for your time. Much appreciated. Thank you, everybody, for coming today. Next week, I'll actually be presenting with Easy Water on closed circuit water treatment. So thanks again for everybody for coming. We will see you next week. Take care.